Hi, Simon here, GM8NYV. I'm just going to have another look at these replica Denco coil formers that I 3D printed. Particularly the nuts here. Now these aren't the original nuts, or not the original shape of the nuts. This is what came off the design that I found online. I say they're just normal nuts here. Yeah, they're just normal sort of hex nuts. Now the originals, they had a distinctive shape, the nuts on there. They had little nodules, I suppose, at the edge, and they were a bit thinner. Screws off there. So I showed these to the Denco course, a colleague at work who was really into his 3D printing, and he thought he could come up with this design here. So he took this as a basis and he modified it, and he sent me the STL file. So I'm going to now print the next lot of formers, which are going to be the yellow ones. I'm going to print them with this type of nut, see what it looks like. Right, this is the Anycubic Photo Mono SLA 3D printer. I've been using this to print the Denco coils. All the compiled programs go on here, and you plug it into the side. The tools, move. I've got home the plate. Now I just lift it by 10mm at a time, just enough to give enough space to put the SLA resin in. So I've not printed anything with this one, this lemon yellow. Let's see what it looks like. I'll try and get it in without making a mess. If you look carefully on that video of the coils being printed, when the plate rises up, I did a little video you can see underneath it. I never noticed at the time, but this is how these coils came out, these formers came out. It didn't really come out very well. What I realized then, I didn't have them vertical on the plate. They're at an angle about 1 or 2 degrees off. I never noticed it on the lychee slicer, and of course I only had one on it, and then all I did was copy and paste to produce the 6 on the plate. So when they finished printing, this was it. So underneath, in some of the holes you can see, and then on the half of it is covered over. Anyway, so once I realized what had gone wrong, I reprinted them. And this is the correct shape. So basically when I was printing it to start with, they must have been tilted over, you know what I mean, by a couple of degrees. I never really noticed that. But these have come out okay. Another thing I noticed, these were on the file I put on the link from that Thingiverse. Now, I didn't realise that the original ones I'd made were off another STL file. I can't even remember where that came from, and I can't find it on my PC. Now then, what the difference is, there's the ones I was producing before, and then this is the other one. It's, trying to get them together, it's a lot smaller. Now of course the nut is the new nut that was designed by my colleague Joe, but you can see the yellow one here is smaller. Now then, This is the original and this is the copy, and that's more in keeping with the size of the original. So there we go. It's worth taking notice of what's on the plate before you start printing. Now the other problem was the hole in the top there was too small for the brass rod, so I'm going to drill it out and then tap it. So this is a 2.5 mil drill, and I'm going to tap it to M3. The easiest way, instead of putting it in a vise or anything, I'm just going to do it by hand. I'll just hold it in a pair of pliers and turn the former into the drill. When I get it started, it's not too bad. That's it. Hopefully that's big enough to go in. Now we can tap it in the same way. So now I'm going to screw that into the tap. This is the size of the former. That's the previous former I made. There's a little ferrite bead, and I'm going to solder that in there. First of all, I'm going to cut a slot in the end. Now to do that, I made this little jig. It's actually the earth pin of a 3-pin mains plug. I just chopped it down, and where the grub screw would go in, I just drilled it straight through and tapped it, so you can screw in the bottom. So on the very top of there's a notch there, so I screw that through. So now I can grip that in a vise, use a hacksaw to cut my little piece there. It's a minute slot. Right, that's a bit there. Put my solder on it. Hopefully get it in. Okay, should be able to get the slot in there. Get that in. Right, and the top side's got the holes marked for the pins. On this design, they don't show through the bottom. This one's 0.7 mil. This one's 0.8. Very small, very fragile. They don't take any sideways movement. They just snap. They're meant really for a milling machine for drilling holes, or you can put them in a Dremel on a stand. What I'm going to do is carefully use them by hand. I use the small one first, just to finish off the hole all the way through. I'm just going to do as carefully as I can. Now the pins I'm using are 0.7 mil, so this is 0.6, just to finish the hole. There she is, gone through. There, just put it out again. I'm going to put the 0.7 in the top there. Just clean out. These protrude about 7mm below. Added to that, we've got 3mm, so I'm cutting them down to 10mm. A rather crude way of measuring it. I'm using these because they've got like a pin head on them. But there's no reason why you can't reuse a pin. This came off, just fold the end over. And just file a small point on here. Just file a small little point. Try and get this pin in. The first one there. Just wiggle it in. Starts to come out the other end. So that's it in. They're a bit soft, these brass pins, but I think the one I made earlier worked okay. I've just got to do another 8. Well, that's it. It's all 9 pins in there now. I'll see if I can get that into the valve base. Will be 9A. And hopefully line up. That's it in. So all I need to do now is to do the windings.